find Fourier transform of gate signal. Find the Fourier transform of gate signal. Okay, now we shall see how the gate signal is being drawn. Okay, over here when we are considering the gate signal is being represented by the function. Let us consider the gate signal function as f of t, and over here this axis is t. The gate signal is taken on either side symmetrically over the time period as minus t by 2 to t by 2. We can also take as minus t to t also, but on the both the side it should be symmetric. Now if I write the function for this gate signal, I'll be getting as f of t is equal to this amplitude let us consider as a. So this is given as a for the range of minus t by 2 to t by 2. Now we have the formula for the Fourier transform. Our formula is the Fourier transform is given as f of omega is nothing but integration over the limits minus infinity to infinity the function f of t e power minus j omega t dt. This is our formula. Now let us put in the formula. So I'll be getting as f of omega, which is equal to, now the limits are from minus t by 2 to t by 2. What is the function f of t? My function f of t is a e power minus j omega t into dt. Now the term a is constant, so I'll be taking it outside. The integration of e power minus j omega t can be written as e power minus j omega t by minus j omega over the limits as minus t by 2 to t by 2. Right, now let us substitute the values in this. We'll be getting as my f of omega is equal to a by minus j omega. I'm taking it outside. The term, I'll be putting the upper limit and lower limit. I'll be getting as minus j omega. In place of t, small t, I'll be putting as capital T by 2 minus e power minus j omega minus t by 2. Okay, now let me solve it once again. This is a by minus j omega this is e power minus j omega t by 2. This is minus, this minus, and this minus will become plus, so this is j omega t by 2. Okay, now this is still my f of omega. Now if I solve this, and take this minus inside, I'll be getting as a by j omega. This minus I am taking inside, so this will become as e power j omega t by 2 minus e power minus j omega t by 2. The places get shifted. Now I'll write in the form of sine theta. What is the formula of sine theta? If I write sine theta, I'm writing the form. Sine theta can be written as sine theta is equal to e power j theta minus e power minus j theta by 2j. Now in this problem I can have the values. I have the values over here e power j, this, let us take this as whole theta, over here minus j theta, but I don't have the term 2 in the denominator, so let us multiply and divide by the term 2. So I'll be getting as 2a by omega. I'm rearranging this, so this is e power j omega t by 2 minus e power minus j omega t by 2 by 2j. Now this has come in terms of sine theta. In place of theta, what I'll be having? Omega t by 2. Okay, now let me solve it further. So I'll be getting as f of omega is equal to 2a by omega into sine of omega t by 2. Now using sampling function, we have whenever we have the value as sine theta by theta, it can be written as sample function of theta. So let me arrange this in that term. So I'll be getting as, now over here sine omega t by 2 is this. So what I'll arrange, I need the same omega t by 2. So 2a by omega, I'll keep this as it is, by sine function of omega t by 2 by omega t by 2 into omega t by 2. Okay, numerator and denominator I have multiplied with omega t by 2. Let me cancel the terms which can be cancelled. Over here we have 2a, over here we have 2, over here this 2 will go, this omega and this omega will go. So left of term is what? The left of terms are t and a. So I'll just write it. This is a t and this is now sine omega t by 2 by omega t by 2. So I can write this as sampling function of omega t by 2. Okay, hence the Fourier transform of the gate function is given as at sample function of omega t by